We can see boundary conditions are very important in the non-linear boundary condition, but well, the main boundary condition all structures have is soil. All the structures will be over the soil, so it's very important to know the behavior of this soil, of the boundary conditions, to analyze in a proper way over a structure and to analyze if there's any sort of collapse due to the soil or extra deformed shape that can increase second order forces, moments, or stresses. So it's very important to analyze in a proper way and in a detailed way what's happening with the soil as well. Well, the example we've solved is the loading and unloading, different cycles of loading and unloading of a clay soil. For that reason, I'm using a CAM clay model. The CAM clay model is characteristic by these two graphs. The first one describes the yielding surface that we will have. We can have inside this surface, we will have elastic behavior, not linear, but elastic behavior. If we go outside this circle, this ellipse, we will have a plastic yielding due to compression. If we move with the stresses in the other direction, increasing Q, we will have yielding due to shear stress. Well, so for this model, it's very important to define this plastic yielding surface in my model. The way to do that is to defining the consolidation pressure that my model had previously. So in that way, the software defined this over consolidation stress. If I'm moving outside this, I will have this relationship between volumes and pressure. That is, I will go through this red line. But if I have an unloading behavior, I go back in unloading, the stress-strain relationship, the volume and stress relationship will follow this other line. Unloading, reloading line, and isotropic compression line. Well, with these two graphs, I'm solving the model. What I have here in the next model, I can see also a very simple model where this the effect of this non-linearity is very easy to appreciate. Here you can see I've solved three different models. I'm going to load the intermediate one. For this model, I've defined a initial condition, initial stress, that is helping me to define this yielding surface. This initial condition, 0, could be 10, 15, or 20 kilopascals meter, the pressure I have over the model. So this yielding surface will be bigger, as bigger that is the initial condition. So yielding will happen later. I'm loading the intermediate model, and here I have the load case I've solved. If I alternate by the name, first is the consolidation state. The first load is solving with initial stress to define this consolidation stress, to define those yielding surfaces. The next one is loading and unloading, loading, reloading, unloading, reloading, unloading, until failure happens. These loads are being increased. If I plot some of this behavior, I'm going to check the results. In example, the last reloading steps. And I'm going to plot in this model vertical displacement in the place where I have my loads. Loads are applied. In that part. So I'm going to plot vertical displacement in one of these points. The node is node number 2. In my results, I'm going to plot y displacement in node 2. Press OK. and this is the behavior I have. First, I have this load, and then when I get higher load, I start having this behavior. That is what the software is doing. As I have a previous higher load, I had an unloading, and now I have my new loading that suddenly changed when I have my load is greater than the previous state I had, having yielding due to compression. If I plot the yielding, salt, equivalent plastic strain, here I have yielding. If I plot the deformed shape, this is yielding I have in my model due to these compression loads. If I compare the three different models, these are the results I get. Here, this is the non-consolidation, not consolidated soil. So when I apply the load, it starts yielding very soon, loading, unloading, loading again, unloading, and the last loading generates my failure with a small load. In my other models, the consolidation load is much higher, so I will have elastic behavior until my loads, in example, the last one with a over consolidation state of 20 kilopascals, I will have this behavior following this line until my pressure starts producing yielding, unload my model, load again, unload, and load again. I can see the capacity of my soil it's much higher, having exactly the same clay, but increasing the consolidation state, I will have higher capacity. And of course, a very nonlinear behavior of this soil that will affect to my structure with different displacement, deformed shapes, and will create me incremental forces and moments and stresses in my model.